join my welcome to that of Engineer Yemi Adeleye, our technical secretary. Thank you everyone for taking time to join. I know it's a Friday evening. Everyone is just finishing off and thinking about the weekend. So thank you so much for taking time to join us for this month's technical session and general meeting. I also want to warmly welcome Dr. Aaron Okorie, our guest speaker of today, who will be our guest lecturer, speaking around stabilizing and strengthening built structures in Nigeria. Thank you so much for that, sir. And our technical secretary, Dr. Kelvin Anno, will give the speaker's bio just before his speech. For those joining us for the first time and who are not NSE members, we warmly welcome you and want to also let you know that the Nigeria Society of Engineers is an umbrella body of engineering professionals of Nigerian origin. The society looks after the professional needs of members through well-structured programs such as this, and the one we had yesterday, which was on air pollution, getting young engineers in Nigeria to design sensors and monitoring equipment for air pollution. So that's something we are supporting as a branch and which we are very proud of, which is being led by Professor Books, our pioneer chairman. We also have a lot of other activities which our members are leading. One of them is the World Water Day event, which Engineer Camille Okedara led, which also had a recognition from the University of Manchester. So thank you for that, Engineer Camille. Last month, we had a very successful event, which was a big networking event here in Manchester, attended by our ambassador, Sarafa Ishola, in which some of our engineers were awarded certificates of excellence for the great job they are doing. So we might not be able to recognize you all with certificates or with awards, but I think what we are doing is really very dear to us as an organization, and we recognize you all for that. At some point later, we'll be listing the names of those who were awarded last month, just for some of them that were not able to join us physically in Manchester. So we really appreciate all this, and we want you to know that you are making an impact, both in this organization and in the general in Nigeria at large. We have membership spread all around. So if you live in the north of UK or in mainland Europe, you are warmly welcome to register with us in this branch. And if you are not an engineer and you would want to collaborate with us on anything else as well, we warmly welcome that, in as much as it's in line with the value of the branch and it will be beneficial to Nigerians. So I want to hand over to our technical secretary now, Dr. Anno, to read the guest speaker's bio and anchor the question and answer session. You can visit our website for more information about what we do as a branch. Thank you so much. Dr. Anno, over to you.
Thank you, Mr. Chairman, and good evening, everyone. Kelvin Anno is my name, and I have a pleasure to introduce our guest speaker today. He is Engineer Dr. Aaron Okorie. Engineer Okorie is a very well-known engineer with over 33 years experience in civil engineering. I've met him in several occasions. Currently, Engineer Okorie has over 33 years in civil structural engineering, and he is the principal engineer structures with the City of Bradford Metropolitan District Council. He's also a leader because he has a whole lot of engineers under him, which he takes care of. He is also he also manages a lot of approvals in relation to the council's highway structural assets in West Yorkshire. Those of you that are around Leeds, Bradford, this area, you might know where I'm talking about. So I wouldn't take much of your time to introduce him because his CV speaks for him. He will be talking about stabilizing and strengthening built structures in Nigeria. And he's going to draw his examples from the practices, the ones that he has built, the ones they've done over the years, over his 33 years of experience. Gentlemen and ladies, help me welcome Engineer Dr. Aaron Okorie, our guest speaker for today. The floor is yours, sir.
Hello, and shall I say good evening or good afternoon, everybody, where you are? Yeah, a lot has been said by Calvin. My name is Aaron. I practice highway structure engineering. When I started off as an engineer, I thought I would be building one of the high-rise buildings, but you never know how fate somehow takes people into a certain area. So I've ended up being highway structures engineer, and I have designed quite a few bridges in my time. Lucky, I would say. So if I can just get back to share my screen, somebody will have to let me know how to get back to it. Yep. Can you see what I've got at the moment?
Yes.
Yes, sir.
Right. This is supposed to be, how do I make this?
Yeah, to the full screen.
To the full screen.
Yes.
How do I do that?
That little cup down right, sir.
It's called a cup. Yep, okay. Right. Can you see that now?
Yes, yes.
Right. So, do we have ladies here at all? Or is it just a men thing? I was going to say
we do have ladies, sir.
Yes, we have ladies.
Okay, bless you, bless you. I'm glad to hear your voice. So, lady, yeah, because yeah, no worries. I'm one of those that encourages women into engineering. I've got at least 3 of them in my team, albeit that one's left and went to America now. But yes, I encourage women into engineering, and they do well. Another thing I wanted to say is that I'm also a supervising civil engineer because I train civil engineers on behalf of the Institution of Civil Engineers. I've been a chartered civil engineer since 1995. So that's really going back as a professional engineer a while. Right, a quick introduction to this, the stabilization and strengthening of Linton Bridge. Linton Bridge actually is in Leeds. And I give you a background information to why we got to that point, or how we got to that point. Linton Bridge crosses the River Wharfe and connects the villages of Collingham to the south and Linton to the north of the river. The bridge carries a 2-lane single carriageway, Linton Road. The river is approximately 40-meter wide at the location of Linton Bridge, which is managed by Leeds City Council, which is where I work. Linton Bridge is a 3-span masonry arch, and we're going to talk about masonry arch here. And the masonry arch, brings something like when you look at the old church buildings, especially in Europe, and it is the same principle that they used in constructing road bridges then. Yeah. On the 26th of December 2015, Linton Bridge suffered a significant structural damage following a storm flood event called Storm Eva. I was the one, because again, I'm on call. I was on call. I went out and inspected the bridge, and that's the problem we had, okay? So a lot happened. We ended up doing 3 phases of the work, what I would call investigating the asset and assessing the damage, initial stabilization of the southern pier, stabilization of the southern arch, and the strengthening of the entire bridge. Now, what I did, I was the brain behind most of the thing that happened here, believe it or not. I went out, inspected it. I've worked a great deal assessing arch bridges, especially the one with network rail. Used to call them rail track, for a very, very long time. And the guy that unfortunately is dead now, somebody called Bill Harvey, was the guy that we used his program. He visited me twice on that bridge to get to where we are now. So if we, let me just click that. This is Linton Bridge, okay? Now, can you see what is there? Can you see the undulation of where this bridge sank? Can you see my red light at all? Hello?
Yes, you can see, sir.
Okay.
Yeah, I'm just hoping that you guys are still with me. Okay. So this was the depression. This was around the pier. This was actually where the bridge sank without. So I went out, inspected it, oblivious of what's going on. And yeah, longitudinal profile of Linton Bridge following the scour. It is really the scour settlement of the southern pier on December 2015. Okay. Now, if you look here, you will see the crack across the southern pier. That was the only observation I made when I went to inspect it. The arch barrel of the center span has a matching crack to that in the southern span, but it's much narrower as shown below. Now, we did some technical investigation and noticed that the bridge actually dropped, okay? That's the central, central pier dropped by about 200 mil, okay? Again, I instigated an diving team that, because again, the way we do things here, you cannot jump into doing anything. You really, really have to have all the information at hand before you can do anything. So these are the equipment here. You know, I was there, but all I could do is watch when these guys went under the river, what they were doing then, okay? And around here is within the pier where you can actually see what happened, okay? The mass concrete that was at that point, they were massively undermined. Again, when you look at the stability, can take you a long way now trying to describe arches for you. Around here is what we call, oh dear, no, go back. Yeah, this is the intradose, okay? And of course, at the top is what we call extradose. And this is really some of the description that you use when you are dealing with arches, okay? So the shaded areas are the ones that are rotating. So what happened is that the bridge actually rotated, and we saw, and of course, the crack I showed you earlier on, that was what did happen. So one of the things we also do with arch bridges over time is that we do what we call saddling. Saddling is a way that you actually just sometimes you reinforce it, sometimes you don't, but you pour concrete on top of arches, okay? And this is what we did, I think it was in 2007, and the thickness here is about 300 mil, I believe. Yeah, that's what it is. Which was subsequently, again, this is the translation at the top. Subsequently, this was what saved the bridge from not entirely collapsing. So we now started work, and you wouldn't really believe it, but you could, because while this happened, people were still trying to drive over the bridge, okay? So it really had to be closed entirely to prevent people from going through. Then we used some equipment here on top of the bridge, okay? This was to help us to determine how much the bridge was still settling while we were trying to think of what to do. And these are just some of the results on the parapet where that we could reach. So stabilization of the south arch of Linton Bridge. We needed to construct a haul road to access Linton Bridge, build a platform for crane loads, build causeway and and platform into River Wharf, install temporary piles, treat pile waste environment, install girders, install wooden cradle with grout socks and fill grout socks, okay? And I'll quickly run through this. So this was us creating the road into the bridge. In fact, if you look there, you can see me up there, not very well, but that's me. And so we have successfully gotten onto the bridge. If you see here, this is where the bridge actually was scoured so badly. And we had to pump in 18 cubic meters of concrete into that area, okay? Right, and this is, again, we're trying to do some imaging on that. A company called BAM Nuttall, that was the company that we used in doing the work. So effectively, we literally blocked the channel in order to treat this area here. And we succeeded in doing that, which then helps us to install piles around this area. Okay. Now, another thing that does happen in this part of the world, whatever you are doing, that the silt that was developed during the trying to drill for the piles had to be pumped into these, what we call silt busters, and sieved, and the proper water drained and everything taken. So whatever mess that we did within the river was not allowed to flow back into the river, because you have problem with Environment Agency. So subsequently, these are the piles, okay? Both raking piles, all right? And that's 300 tons mammoth crane that we use in installing a cradle in order to hold this arch. One of the reasons why we're doing this as well is that this is an English heritage grade, English heritage grade 2 listed structure. And a grade 2 listed structure is one of those that in this country you have to pay quite a lot of money in order to maintain them for what they are, because it's part of the heritage. Again, we do what we call stitching. We try to stitch these arches both from underneath and at the top. We get to the top when we come to that. Okay, and this is what you're looking at here is a stainless steel. Okay, that is used, and they go into these tiny holes across. In order to support the cradle, we pumped grout from here, okay, onto the wooden structure that we had underneath. Okay, here is where we have what we call grout socks. The socks is supposed to hold that arch so that it does not have, because everything we're doing is to protect this stone structure that was built in the 17th century. Okay, that's really part of what we're doing here. Now, after that, this is where the modern thing comes into play. Everything we're trying to do here is that I ended up building a bridge inside a bridge. And this is the model of what we did. So we had piles on the abutments, okay, 2 piles, and we then have another piles in the piers. So this was the model we used, and from finite element, which my guys did. So this is what we ended up with. And for those of us that do AutoCAD, you begin to model what these are the piles, okay, as we envisaged it, and subsequently it did work. If you look around here, you will see that we have, again, I'll show you when we get to that point. Okay, we have to weld steel onto those piles in order to create shear connectors with the reinforcement when we did the pile caps, okay? So many of them, pile length through the pier in perspective, 27 meters long. Right, this is typical how the piles were made. So you stick in the piles, you screw this onto that, the whole 27 meters is what you get, okay? And on top of that, you stick in this one single, can you see my cursor there? Okay, you will, this is actually put inside one of these, and that becomes the pile, and we have them there. That was me trying to inspect from underneath the bridge. We use high strength cement, okay, not just ordinary cement, in order to go into the piles. And by the way, the steel reinforcement is 40 millimeters thick. So we carried on grouting piles, and after that, again, as you can see, we pumped in concrete in each one of these, okay? Sequence of pile cap construction. Excavation to expose piles. Back of wall construction to tie spandrel walls to pile cap debonded. 75mm concrete blinding. Welding shear stud, I mentioned earlier on, to pile head. Threading reinforcement through alternate piles and main reinforcement. Installing duct for statutory undertakers. That's another thing was really a big problem, that whatever you do, you've got to remember that here, all our services are buried underneath, okay? So this is the piles. So we had to excavate, expose them. But an interesting thing here is what see my cursor here, what I'm showing here is what we call jack arches, okay? This jack arches is one of the way that these guys designed the stuff, okay? Because in those days, you don't have steel. So everything acts in compression, okay? And all the jack arches, because most of the railway bridges, again, in this country, they are done with jack arches, really, in order to maintain the strength. So we use jack arches in order to create, this is a run-in for the main bridge structure, okay? That's what it is, but now I'm getting rid of it somehow because of, okay? I'm now creating a new, yep, that's what we have now. Subsequently, and the 75mm blinding, and that's the shear stud, okay? We have on the, again, we have this, each one of them, we have reinforcement to go through the pile, okay? So we cut those through. And back in Nigeria, we call this a biscuit or whatever it is, because on top of this now we put our reinforcement in order to allow, okay, the concrete to cover that properly, despite the blinding. Because more often than not, the strength of the blinding concrete is not the same thing as the proper concrete that we're actually doing on the bridge. Okay, again, this is it being constructed. And here you are, this is the pile cap, okay, for the abutment. And all this, again, has to take the statutory undertakers apparatus, okay, gas, BT, and Northern Network, as in electricity. We made provisions for them, and water, okay? Right, that's yeah, that's the pile cap now completed for that side. Now what we now do on the other side is, this is like the main part of the structure. We now break them up. What you're looking at was the, what did I call it earlier on? The 300 mil concrete we had on top of the bridge. The saddling that saved us from the total collapse of the bridge. Okay, so here we are, and you can now get the idea. So again, what we do, we scabble the concrete in order to allow the next phase around here to key into, so that all of them can act in unison. So deck slab over the central and south arches. That should be a B in our slab. Expose cracks, clean and stitch cracks, remove 2 courses of brick from southern arch to achieve required depth thickness, install reinforcement to top and bottom, and install service ducts for concrete, okay? Quickly, we go through this. Now, this is how we stitched, okay, the crack on the arches, okay? It goes across, and that's what we use, arch barrel cracking stitching. Everything I'm showing here are available to be given to individuals. Now, on top of the concrete, on top of the extrado, you now see, having cleaned it out, this is the crack, the translation of the crack from underneath, okay? So that's another one. It's just that they tend to be not as bad, but that shows that the concrete is no longer, or the arch is not as good as you expected, therefore something, which is exactly what we are doing, something has to give. Okay, this is method of actually stitching the concrete, stitching the arch. Okay, out of all of them, these are the position of the stitching. Okay, and this is actually how the stitching are done across there. Guaranteed. These are tested. We're not just messing about here. This has been tried and tested over the years, and we're employing it here. In order to maintain, as I said earlier on, we needed to have 300 millimeter thick concrete. So at this point, we had to remove 2 courses of brickwork so that we can achieve that 300 mil concrete. Okay. And this is subsequently what we have in reinforcing the deck. Okay. And this is the southern arch. Concreting. Voila. We have the bridge on top of the bridge now. Now we have the bridge now inside the bridge. Okay. So from outside, you wouldn't really know what's going on. And another thing I have to say, when you look at the reinforcement and everything, plus the piling that's gone in, that this bridge was also designed to take what we call 40 tons, okay, of traffic load, okay? Or these days we'll call it a load model 2. For those of you who are into highway design, we call it load model these days, as opposed to HB loading, which was the original British standard. Okay. Now, because this bridge is listed, we're now going to, yeah, that's another thing. Something called spandrel wall. Spandrel wall is the bit that is below the parapet. We had to now tie that spandrel to the deck, and that's what was being done here. I hope I'm not rushing this too much. Another thing that we do, part of the English heritage requirement, when you're actually dealing with listed structures, is that every single stone on that parapet was numbered, and they had to go back exactly where they came out from. Okay, and this is how you deal with. Again, we got some dispensation because, like this one that's cracked here, okay, we were allowed to replace it with a new one. Otherwise, you would have to find a way to, which was not really worth the money that it will cost to deal with that. And After we've done the bridge, we do what we call, okay, this is waterproofing. You can see it has a distinct color in order to just let people know if they were supposed to be digging it up from top when nobody's there. When they reach that, they will know not to go beyond this. It's like a red flag. And these are also signs that Northern Power Grid put there so that you know they've got their apparatus underneath. And again, water, BT, they're all there. A lot of activities. We were also, I happened to be lucky enough, I could use the drones to take some pictures of what we were doing then as well. Yep, subsequently, we were now trying to complete, and so now you can see that we have a bridge inside this. When you are going on top, you probably wouldn't really know what has happened, but this is us on Linton Bridge. And in a typical English style, what you see here is, you may laugh or you may not, but somebody was so excited they carried their dog like that. And that was me on the opening ceremony day. Again, providing some radio interview, because I spent 2 years of my life rebuilding this bridge. Okay, that was home at some point, as I was the project engineer for it, and the approval process that went with it. Prior to this, I went to the radio station and gave 2 interviews at different intervals. And this is it, the expression on their face after we've done it. And what I can say to you, my people, is that having done this, the expression on this face, it was one of the epitome of just part of the engineering. After you've done something, you feel you've done something for a community, for a society, it brings out the engineer in yourself. And that's how I felt when this was done. So on this note, I would say, yes, done now. And I'm happy to take any question. I know I've rushed it, but I'm also told of the time. It's only about so many minutes that I have to say this. I'm sorry if I appear to have rushed it, but what can I say? It's just to show that there are so many aspects in this bridge of what we did. Because first of all, we had to hold that thing up and did what, in fact, that part of the contract cost about £2.something million. Okay. And subsequently, when we finished, we had to get rid of all the piles that we had inside the river as well. So as if nothing's happened. And whatever it is we did, we cleared, and you know, it's a lovely sight, really, making things good as well. That's where part of the money is spent. Thank you very much. And how do I come out of this again?
Thank you very much. It was nice having you present to us. Let me also apologize to everyone because of time. He had more of these that he wanted to present, and it was me that was saying, because of time, let us cut it down. I know I have a lot of civil engineers in the house who are more than ready to bring on their questions. Engineer Camille, please.
Thanks, Dr. Aaron. Am I being audible?
Yes,
yes, we
Go
can hear
ahead.
you.
Okay, fantastic. I don't know. I've got a couple of questions. I don't
Go
know.
ahead.
Maybe I'll just ask a few, and if there is time, maybe I can come back to the other one. But let me start by appreciating Dr. Okorie. I think one, this is an eye-opener to a lot of us, and I congratulate you for the achievement you have recorded in your profession and in the UK. Having said that, I am in the water industry,
Okay.
and we've got some similarities. If it is structure anyway. So one, how did you conduct the integrity of that bridge? That's my first question. And then the second question is this: your remote pumping. Were you doing e-pumping?
How do you mean e-pumping?
You said remote pumping. I wanted you to come to our level. When you said remote pumping, I was thinking probably it was an AI application. Probably we're doing e-pumping.
No. There were two things that happened there. I think if I can quickly now, I wouldn't really get there. One of the first thing we did in order to understand what happened to the bridge, okay, originally was
Are you able to leave your screen, sir?
oh yeah, oh dear. Okay, then I can just, yeah. One of the thing we did with it was really a very scientific thing. I had to get this company from London to install something for us to monitor. We used again solar, and just like most other thing, with a SIM card that was transmitting whatever that was happening on top of the bridge to us. The remote pumping that came, if at all, was that we had to build that causeway into the bridge and used a very, very remote pump. Nobody could get to the bridge anyway. The bridge was, because of our health and safety rules here, you could not get to the bridge within 5 meters. So we had that pumping machine that did the 18 cubic meter to the 18 cubic meter to the pier in order to create the initial stabilization. Because don't forget, when the bridge failed, it tilted and was going down almost on one side. Okay. Right, your next question.
Yeah, so my next question is actually bringing you a bit to Nigeria.
Okay.
I was at one of the water utilities in Nigeria recently, and they had problem at the barrage. You know, a barrage is more like a well. So they had problem with the barrage, and it was actually difficult, you know, to actually divert the water, you know, looking at the level of technology around. But I saw that when you were actually undergoing that maintenance there,
the investigation, yes.
Yep. Yeah, I saw that you were able to actually, you had almost absolute diversion of the water. So what approach did you use, and how do you think such can be done in Nigeria?
It is doable. You just have to have the mind. You also need to have contractors. Everything is, if I say, I'm not trying to be silly here, Everything is possible if you have the money to do it. Okay? Because we literally backfilled that water. We created a channel. We literally backfilled the water with materials that we were able to take off again because we used stone, okay, to do it. And of course, this stone was eventually taken out and used elsewhere. So first of all, you need to think about what it is you want. I don't really know how to say this now, but when you are building a new structure or not, something called the temporary works. So if you're not very careful, temporary works can cost more than the main job you're trying to do. Okay? And the part of the temporary work is also where you have most accidents as well, part of the health and safety. So you need to be very careful for you now go to the client who provides enough money to make sure that all these things are possible. So as an engineer, you need to look at your risk assessment very well and ask for the money. If the money is not there, don't do it, because you are putting the profession into disrepute. And before you know it, people will die. And hoping it shouldn't be you. That's all I can say.
Yeah, but based on that, I don't know. Do you have any company that you think has enough experience in barrages like that you can recommend?
Well, yes, even like the guy that did this job for us, they work in water and everything. I can put you through to BAM and Co. And whether they operate in Nigeria and places like that, because of our reputation, is a different thing. But when I say anything is possible, there are engineers, including myself, that can go through, because most of the thing first, like before we did what we did, what you just saw here was me presenting. I spent some good time trying to design, because I do design myself anyway, before we came up with a plausible solution and sold it to the higher management, directors, everybody. But when they see the caliber of the engineers trying to do the work, they have no problem by saying, right, you go ahead and do it.
So Dr. Kelvin, please, probably you do the linking after the meeting, and I can collect the details.
Copied, sir. Copied.
Okay, thanks a lot. My last question for you, Dr. Okorie. For lay people like us, you said you were stitching.
Stitching, yes, yeah.
Yes, I wasn't expecting the stitches to be wool anyway. But what determines the material of the stitch? And in that particular instance, what material did you use? I'm talking about the specification for the stitching.
As I said, it's a stainless steel. You know, stainless steel, they don't rust. Okay. Now that stainless steel is twisted as well. So you have something they cross like this. You saw the picture I showed before? They cross like that across that crack, and that's what's held it.
Okay, thanks a lot.
Yeah. Now, and another thing, just going along that way as well. When you think about arch structures and brickwork, what actually hold that brick? Okay, you had the interface between two bricks, or two, call it even like our cement, is the mortar. And this is where you also need to be, I can be taking you into a different area now, because you need to be careful with the strength of your mortar and the two things that is supposed to be holding together. If you mismatch it, you create cracks. Or not, you create cracks will result anyway, sorry. Yep.
All right. Thank you, Engineer Camille. Engineer Godwin Okuibe, please ask your questions.
Good evening, everyone. I hope you can hear me.
Yes, very well.
Okay, thank you so much, Dr. Aaron, for your presentation. It's always interesting to listen to elders like you in our profession. So mine is, I will first say that I'm not a civil engineer, I'm an electrical engineer. So mine will be like a general context question that I want to understand. So from the topic, it's stabilizing and strengthening built structures in Nigeria. So I was thinking that this is a Nigerian case study. So I want to know, are you telling me as a young engineer that I can apply straightforward what you applied in the UK in Nigeria? Are there other studies that I need to do before I can apply this in Nigeria? This is what I want to understand. I mean, this is, to me, I'm not in the field, but I see that it is a study in the elite. If we are to do the same in Nigeria, what should happen? What are the changes? What can we do? What can we not do? This is what I want to understand. Thank you.
Right. Thank you very much. You really excite me here because what you qualified as was my first love. I read electrical engineering in the good old days, and you'll be surprised what I can put together. Anyway, having said that, yeah, you can do, let's go back to what we call codes of practice, okay? Today, my question really, and I keep asking that question, in my Nigeria, because I still have people I work with. There is something I saw here, the introductory part of this that says you missed, okay? I'm digressing a bit here. Believe you me, my colleague that we all came to this country the same day actually graduated from UMIST, University of Manchester Institute of Science and Technology. Okay, he graduated in 1982, went back to Nigeria and became the secretary for works in Enugu, Fred Okorie. Anyway, so what code do we use in designing anything in Nigeria? Do we have a code? If you talk about, let's go back to where I work, civil engineering. What is our code for designing anything at all? You see, here in England, we use what we call the British Standard, which subsequently became Eurocode. Now, before you castigate us, I can tell you that more than 70% of the people that wrote Eurocode were British. Okay? Going back from London School of Economics, you just name it, where you have the super engineers, professors that wrote the Eurocode. Now, the difference, assuming that Nigeria is adopting Eurocode, which is what we use in designing what we just did, okay? All will change is what we call national annex, depending on how you spell it. And the only difference in national annex is just the environment, temperature, okay? The same thing happened. Usually when I go on holiday, say in Greece or places like that, the way they build their bridges is different because of the joints. I've actually seen similar thing in Nigeria, in Enugu, okay? That the bridge joints were reasonably okay, and I believe that that would have been done by people who understood what joints in bridges are, okay? So unlike we tend to be extraordinarily careful with that here because of our weather. Okay, back over there, it's different. So we make room for something like that. That's all I can say to you. Yes, it's doable. You can design it based on what I've just presented here. The only difference is just use the environment. And most of the time, which again, I doubt, but if we do, that's fine. That we've studied this country very, very well, that most things are recorded. Okay. More questions? I wonder if that answered your question, please.
There
Yes,
is a
thank you
follow-up
so
question,
much.
sir.
Pardon?
Yes, thank you so much.
Yeah, okay.
There's a follow-up question, sir. Engineer Diaye says we use BS code to design in Nigeria.
Okay.
And then he believes it's the same thing that the British standard. I don't know how that flows with that question.
Yeah, it does a little bit. And I'm saying Nigeria just happened to be lazy. They shouldn't be using British standard because it's old fashioned now. Okay. When I say old fashioned, it's no longer in vogue. If they're following the British way, they should be using really Eurocode, because Eurocode has been adopted by so many countries, Malaysia, you just name it. But the only difference is what I call this national annex that we ought to have in Nigeria, people who can map out the temperature of the whole of Nigeria. For instance, the temperature variation, say like I did my national service in Kano, the temperature, and that was 1983, by the way. When you look at the temperature, if you're building a bridge there, it shouldn't be the same thing as if you're doing it in Enugu anyway. Because that temperature variation is what you plug in to determine your expansion and contraction. Thank you.
Okay. Thank you, sir. Thank you. Engineer Robert Ataria, your question, please.
Oh, thank you, Dr. Okorie, for the presentation. Yeah, and just a follow-up. Actually, the Nigeria education system and practice, I think, is same thing with what we have over here. Thinking our school systems right now, I think they're actually using the Euro codes in terms of their curriculum. And the same thing with practice. Regarding the national annex, I think the NICE, I think Nigeria Institute of Civil Engineering, I think they've come up with something related to the national annex when it comes to design standards in Nigeria per se. My second question is, I think this is a difference. It's the same scenario anyway, but in terms of complexity, it's different. So the last time I visited Nigeria, actually they had this sort of coastal jetties. If you should be familiar in the coastal, a southern part of Nigeria, where there's some of these projects that have been executed by NDDC and the rest, but they have this sort of a scenario where uneven settlement occurs in one of the those jetties. So what happened is one of the pile, like what you've mentioned now, is sort of settled, so to a sort of a high degree, and massive amount of cracks generated because of the internal stresses that occurred as a result of the settlement.
Yeah.
Now, this is a small structure. So considering going into rehabilitating or sort of getting that structure to a stable state. Yeah, like my concern was what the economic implication compared to coming up with a new one with more sort of integrity could be more beneficial instead of wasting funds going into rehabilitating such structure. Like the one you did, I quite understand is a listed grade structure. So regardless of the cost involved, one can actually close eye and go ahead with rehabilitating such structure with enormous amount of cash. But considering Nigeria and the size of the structure and the economic implication, and even not even having that certainty that after rehabilitating this sort of structure, you get what you're actually looking out for. So it's just a general advice that one can get from you regarding this.
I think you've actually said it all, but I dare say that I'm disappointed in a sense that you are not particularly, say, forceful about what you could offer there. And this is what bemoans Nigeria, that we don't have grand structures. In terms of doing that, yeah, differential settlement will always cause stress and it will create a problem. And once it's there, you need to now go and look at the risk assessment. Yeah, you actually mentioned something. Nobody has an infinite amount of money in order to do something. But again, do you have enough land to build a new one? These are things which we would consider here, okay? Do you have enough land to build a new one? What is the cost of actually building a new one vis-a-vis trying to see how we can jack up this other one, recreate some tiles, okay, in order to bring it up to, because as we speak, I can just dream about how it's possible to actually do it, okay? The other funny thing is you are talking about something that's happening, say, underneath, because somebody would have to go underneath, diverse, to make sure that things are done well. And they cost money, okay? When I just that thing I did there is about 5-point-something million pounds, okay? But trying to jack up the bridge, stabilize it before we actually socket another bridge inside an existing structure, and nobody knew what happened. But the community were very, very happy. We built for the nation. So I'm sure the same thing can happen in Nigeria. We just need to understand, look at the money. Who's actually bringing the money? Who's going to be controlling the money? Where does the engineer come into it? Are you just on the periphery, which I never was? If anything, I was controlling that money. Okay? To say yes, and I was signing off that money as well. I didn't see any penny of it, but what I saw was what we did, and it was good. I felt £1 billion within myself that we did a job that I could be proud of. Now, once we imbibe that kind of understanding within us, anything is possible. We've got the brain anyway. What are we talking about? We can do things. We just need encouragement for our ideas to come out for the nation, Nigeria, irrespective of where it is. I wonder if I answered your question.
Thank you, sir, for that question. I think I should take the very last question from Engineer Mrs. Onoma Okorie. Your question, please.
Yes, thank you very much, sir. And I want to quickly appreciate Dr. Aaron for his impressive presentation. I am actually not a civil engineer, but from background of electrical engineering. But your presentation taught me so much. And to add to that, I am from the riverine area, where currently a bridge is proposed, a new one and another one to rehabilitate. But in this climate, in this part of the world, most times we see that these projects, they last quite long, far longer than the period within which we were able to complete yours, even though it may not be exactly the same job to be undertaken. So my question is, was your project completed within the time and the cost allotted for it? If yes, how were you able to achieve that? Because over here, most times, ours is not the same. Oftentimes, in fact, the project will even still be on until maybe another administration that wasn't there when the project was signed into construction, still coming, and oftentimes, sometimes they even get abandoned. They say the cost has been overrun or the time and all of that. So how were you able to manage your own project to be able to deliver within the time and the cost, if you were able to do that? Thank you, sir.
Yeah, no worries. Yes, we did. And it was completed exactly when it was supposed to have been completed. We did it. But one thing that, yeah, when I say that I was on top of everything that was going on, I had a design company that was based in Sheffield. And I was the one with one of my engineers, Bowen, chap from Zimbabwe, who is another fantastic engineer. Okay. Two of us used to go to Sheffield to look at what the issue is. These are the design stages. Okay. It's not just the engineer being engineer on site, but it's engineer who understand what we are doing and how we're going to make things work. So, like I showed you our design principle, the bit that had the finite element things about a pile and just in a graphic form. All those ones, when they were doing it, they were now able to find that certain things were not working. We now try to find a solution from the design stages or from the design principles. Now, when anything, the cost of the material goes up, from what we call project management, you report up. Okay, I was also the project manager. So we have board meeting, project board, where you report whatever is happening. You don't sit on it. So everybody knows what is happening. That's how we managed to control what was going there or what was going on. Okay, so when it comes to the way we do things in Nigeria or how contrast gets awarded, first of all, even before you do that, you actually need to now, do you do your risk assessment, your design, all the things that are going to be involved? In fact, when I say to people, I'm doing a job now here at the moment, I cannot say so much about it because it's all political and because of who I am as well. But just all this trying to find how something is actually going to happen, we pay, or we've actually spent more than £500,000 and we haven't even designed a single thing. Okay, consultation, finding out what's going to happen. Okay, and everything is pure 100% documented. So can we do something like that? You have engineers, and engineers, not politicians, engineers that their job is to design, that we have affinity for what they are doing. And they can feel proud of that after it is actually done. That's what we need to drive us. Not thinking, well, I'm just starting. I'm not even sure this is going to happen in 2 years' time anyway. How can you actually become even this year a proper engineer that you crave to be? As I said, yeah, I've been extraordinarily lucky. I've designed some fantastic structures, both in Leeds and so many. My word, I designed 8 lanes, 50-meter across the River A. That was 2002. Fantastic work. Okay. You know, so there's quite a lot we can talk about this. Anyway, more questions, if at all.
Okay. Just a quick, sorry, Dr. Just a quick one. You mentioned that you are a trainer with the IC. I think, I don't know how that could be beneficial to most people in the platform. I know most of us that are working with the company, I think our companies are taking care of us by assigning a supervisor to the training scheme in of the IC to get to chartership. And I also know there is a different route which you can get sort of an external trainer to actually see you through the entire process of the chartership. I don't know if you can throw more light on that. It might be kind of beneficial to some people within the platform that are looking out for routes towards chartership. Yeah.
Yeah, thank you. Yeah, that's a good one. Yeah, not only am I a supervising civil engineer for Bradford Council, I'm also what you call a mentor. Again, on behalf of ICE. I dare say that the mentorship is a lot of hard work. Okay, let's say that I don't know where you got to in the realm of all these things. Let's say that I want to mentor you now. Okay, we can start from a point where you may not necessarily like me because I will be letting you know that maybe all the things you thought you know, that you don't really know them. I don't know if I'm making sense here, okay? So that you can see what this ICE method of wanting to train you as an engineer is all about. They don't want to know your qualification. You've already used that to get to your point. What they now want to know is your ability to be able to talk about what it is you are doing. I don't know if that makes sense. Now, that ability is they will go to your engineering understanding. Okay? After your engineering, of course, you look at health and safety and quite a lot of other things, and they will also look at your ability to not quite to just understand engineering principles and the application of the engineering principle in the first place and the application of the engineering principle, how you actually bring all of them together. Because to have the kind of chartership, you know, that I train people into, and I've been lucky, some of my people I'm sponsoring, they have been going through and passing, is that what you don't know, just to say you don't know it, it's not the end of the world. Okay? If somebody asks you a question about a particular engineering activity, but the only way you put your foot in it is trying to claim you understand. In fact, if you are saying it, people can see gaps. They can just see holes through you. They'll say, this guy doesn't know what he's talking about. And you think people actually failed you. No, they haven't. It's just that you haven't sold yourself well. So yes, I do mentoring, and my mentoring is going through the list of, I don't manufacture it. ICE has a list of what we call, oh dear, objectives. Okay. All the about it used to be 9, it's now 7. But they haven't reduced it to 7. They just joined up some of them into 1. Okay, so it's still the same 9. And each one of these activities, you need to understand it very, very well. Okay. There is the ING route, but to be a chartered professional engineer of the ICE, you need to really be an all-round engineer within the civil engineering environment. Don't forget, if say for instance, if you are in the water industry, people don't expect you to say no things about the traffic, for instance, okay? And you'll be asked questions around water industry then. And of course, people that would interview you would come from the water industry. That's how it works. If you're in highway, they will also do the same thing. They will ask you questions from the highway, not necessarily highway structures, which is my expertise, okay? It might be designing on highways and things like that. And like most of the thing happening there, we use this AI to control the way traffic move around in the city. If you specialize in urban traffic control, they will want you to know everything and how what you are doing affect human beings traveling in their vehicle and how civil engineers are doing things to make that happen. So all I'm saying is, there is no one something catch-all, but wherever you are, just to specialize in it and be able to talk about it within the civil engineering industry. I don't know if that's been useful at all.
Can I add to what Engineer Ataria was asking? We have a few young engineers here who are aspiring to register with them. Is it possible if we pass them on, some of them, for you to assist us with mentoring them?
Yeah, and they were, oh, well, to start with, to mentor somebody, yeah, I can, but okay, with a massive but. Their qualification has got to be, or have got to be, yeah, has got to be acceptable to ICE, which has nothing to do with me. Okay? So if you meet the requirement of the ICE, where they say you could register or train to become a member of the Institution of Civil Engineers, then if you search, you will see my name as a mentor, okay? And we could be linked up that way. I don't know if I made sense.
Okay.
And from there, we take it on and we can start asking each other questions. And of course, the ICE don't give up. They will be wanting to know what I'm doing with you as well.
That's okay. That's okay. Thank you very much, sir. I really appreciate your time and this massive expertise that you've delivered to us today. And I would like, on behalf of the Nigerian Society of Engineers, the Manchester branch, UK, to say a very big thank you for your presentation, and then for offering to support us and support the young engineers. Just to mention that there might be more questions that might pop up after this, and then based on your expertise, that some of them from, because we have some engineers that have joined us from Nigeria, and they might be consulting for some, for your opinions on certain things. So we'll pass those questions on. Thank you, sir. Thank you very much. For just before I hand over to the branch chairman to give his own vote of thanks, I just want to mention by way of announcement that beginning next month, we're going to have a parallel session, workshop session, where we will have some additional technical presentations from engineers, from colleagues as well. So on 15th of September, we will start the first session, and I will be sending out the flyer. So please look out for it. And that doesn't cancel the last or the general session that we usually have at the end of every month like this. So we're going to have another session by the end of September, and we all have the speakers all lined up. So I will be sharing their profile as time goes on. Thank you very much, everybody that has made effort to join us today. Kelvin Ano is my name, and I am the technical secretary for this branch. I will pass on the baton to the branch chairman, Engineer Patrick Obidoyin. The floor is yours, sir.
All right. Thank you so much for brilliantly anchoring that session, Dr. Kevin Ano. I know we've run slightly behind schedule, but I think that's where, but it was quite interesting. And I think the last question was more around mentoring and professional registration. So in a way, we're using one stone to kill many birds. And thank you so much for that, Dr. Okorie, because I think having someone of your capability and status with the experience of mentoring civil engineers to become chartered engineers, we would really want to continue to have that relationship with you as a branch to ensure that our civil engineers in the house have access to have their competencies analyzed in order to be able to fulfill that requirement to become chartered engineers in the UK, which would automatically give them access to current registration. And just in line with, so we're going to make this, so be patient with us, Dr. Aaron. We'll have Dr. Ataria. So Dr. Ataria, get ready. You'll be giving the vote of thanks on behalf of the branch. So because we've run out of time, we'll quickly take some announcements, and I want to quickly go to that announcement which Dr. Kevin Ano mentioned. Just to quickly say that come mid this month, as part of the trial which Dr. Ano talked about, we'll be having a presentation around enforcement of engineering ethics and regulation as a prerequisite for sustainable national development. And that topic will be taken by Engineer Ali Rabiu, who happens to be the immediate past current president. So please watch out for the flyer of that particular event. And also, we are very pleased to have our branch patron and past president of Nigeria Society of Engineers joining us in person of Engineer Ademola Olorunfemi, FNSE. Thank you for joining us, sir. Earlier we had Dr. Books on. I'm not sure if
thank you so much. My pleasure. Sorry I came in late, but that was awesome. Dr. Okorie, well done. I can boldly say we're proud of you. Keep it up.
Thank you.
Thank you very much, sir. So earlier we had Professor Books on. I'm not sure if he's still on. He was our pioneer chairman. And we're also honored to have Engineer Demola Aguro, one of our sponsors for the event we had the last time. I'll give you some time to make some remarks, but we just want to recognize that you are there. Thank you for joining us, Engineer Demola Aguro. Then we also have Engineer Baton Barry Lezo, who has also asked for the guest speaker's presentation. I know, Dr. Aaron, you did mention that the presentation slides will be available to those who require.
No worries.
Yes. Okay. Thank you very much for that. So I just want to make sure I'm getting that confirmation while he's on as well, to make sure that so Engineer Batom, that will get to you and any other person who is any other engineer who is interested in those slides. We also have another lady with us. I think Engineer Deborah Ebem. I think this is probably your first time of joining us, but we are pleased to have you. And as Dr. Aaron Okorie said at the beginning of the presentation, he's more interested in getting more ladies to become engineers. So we are glad to have you on, madam.
Thank you, sir. Yes, I just joined. I'm just coming from an interview in Ogun State. I just got home and joined. It's a pleasure. I'm in Ogun now.
All right. Thank you, ma. So,
thank you so much, Ajay. Thank you so much.
All right.
Thank you. Everybody need the slides, so.
Okay, all right. So I think if you could place your email address on the chat, Dr. Kevin Ano, if you could pick them up from the chat box, then we would be able to get it across to those who are interested. Thank you for that.
Yes, we'll do.
Okay,
I will do that immediately. Thank you.
Okay, thank you, ma. So I want to quickly mention, but I think from next general session, we will be having the logo of our supporters or corporate sponsors displayed at some point during the event. So I just want to quickly mention Protogy Global Services Limited, Calix Drinks, which is a drinks company in the UK here, North to East Invest, Salter International, and Sackville. So we are pleased to have those corporate sponsors. Oh, all right. You have them. Thank you so much. Yeah. So those companies actually were instrumental to the success of the last event we had on the 22nd of July, which was really very successful, and in which the ambassador of Nigeria to the United Kingdom, Ambassador Sarafa Ishola, was present, and a host of other engineers on this platform were present there in person. Thank you so much. So Dr. Okorie, hopefully we'll be getting you into some of our future events. We'll make sure you don't leave us, because we believe you have values which we have to tap into, and which a lot of our young engineers need to tap into. So during the event last month, we did request, and I think this was all thrown out to everyone, to nominate engineers who have had impact. This was thrown open to all engineers, and we had 2 nominations coming top. One of them is Engineer Laura Uhiara. I don't know if she's here. So she was nominated as the most impactful engineer, female category. Engineer Laura, are you here? Okay, if you are here, you can unmute yourself or signify by raising your hand if you've not joined in that name. We also have Engineer Ademola Agoro with us here. So they were nominated as the most impactful engineers, and we did mention that during the event, but because he couldn't make it here in person, Engineer Ademola Agoro, if you could say a few words, please. Thank you, sir.
Thank you, my chairman. I want to use this opportunity to thank the entire Manchester branch for the nomination, and to our speaker today. I listened to everything you said from the beginning to the end, which I quite interesting. But one thing that I just want to say here is that when you speak about the job, you are talking about somebody was asking you about a question about whether you did the job to time and to cost. But I hear you say that even the money you spend on maybe I'm not a civil engineer, I'm an electrical engineer, but I can count it as part of the preliminary work, especially the cost that you use for the diversion. That's one of the reasons that we have issue in Nigeria. The road, they are doing a road, Julius Berger and one other company is doing an express road in Nigeria today. There's a lot of traffic because they never planned for alternative roads. No money was budgeted for alternative road for people that are coming to Lagos. Because of that, the job overrun, it increases in cost. So if Manchester branch, some of these presentations, we have an engineer in the Federal Ministry of Works now. If it's possible to have all these things in the kind of a document that can be shared to the headquarters, and some of these things can be shared with them in the Ministry of Works, it will be able to help in different projects in Nigeria. On the issue of knowledge, I thank the entire Manchester branch, and I think that will propel us to be able to do more. Our vision really in Protogy is to build young engineers, and anything that we are doing in capacity building, we saw it as our own CSR. The art of what God has given us, we can give that back. Thank you once again.
All right, thank you so much for that, Engineer Ademola Agoro. And I think just to quickly mention, substantial nomination was talking more around your impact with mentoring young engineers, which I believe Dr. Aaron also shares that values. So thank you so much for that, Engineer Ademola Agoro. Okay,
thank you, sir.
Yeah, can I just say something from what Engineer Agoro said here?
Go ahead, sir.
Regarding traffic management during construction under the Nigerian style. Now, yeah, I can see that as being a problem, but it is a no-brainer that before you start work, you have to anticipate, okay? And plan around that. I mean, I can understand Nigeria is Nigeria and whatever, but can we not make it any better? We can. And these are all planning ahead before you get to that problem in the first place. We are doing some work in Bradford here. There is a sign telling people, if you're going into city center, you're going to have delay, look for alternative route. There is, I mean, it's nothing but information that you can tell people what to do. They might even decide not to travel on that particular day than going on the road and getting stuck for a very, very long time. Before you know it, somebody's died from heart attack and high blood pressure and things like that. We can all help by just planning, thinking, empathizing, putting ourselves in the position of the, it's just one of those things. So what? So we are engineers, but 1 minute we're engineer, 1 minute we're also traveling public. These are the way we look at what we do here. Believe it or not, I'm more of a politician than even the engineer, because the people I'm working with are, on my neck every time. All the letters I'm answering is how I'm not trying to say how I wriggle out of. No, because before I do that, I have to ask my staff, what's happened? Okay? Because people are asking questions and things like that. And because when you're dealing with the public, yes, the engineering thing, you put it behind you. The other one is, how are we going to work with the ordinary people? That's all. So yeah, I appreciate what you're saying, but it's really a no-brainer. I think we must think about the people we are working for, especially in civil engineering work. You don't work for one person, you work for the community. Thank you.
Thank you very much for that, Dr. Aaron Okorie. And I think, though I'm not a civil engineer, but I was able to appreciate the amount of work that went into the Linton Bridge, considering the amount of time that bridge was out of service. And I believe your communication with the community would have helped to smoothen that part with regards to how they they feel the impact, trying to make sure that the impact felt was commensurate to the joy, which was captured in your last screen about when the project was completed. So moving on very quickly as well, during the event last month, we had the Award of Excellence for some of our members who have been working tirelessly on behalf of this branch. One of the recipients was Professor Yunusa Kaltungu, our pioneer technical secretary. So he was a recipient. We also had Dr. Adenyaju, our immediate past Assistant General Secretary, and Dr. Lillian Iheukumere Esotu, our current Assistant Membership Secretary. And also, last but not the least, Engineer Adeyemi Adeleye, our current Membership Secretary. And I think what he did actually was displayed in the way he took us by surprise by making sure that those sponsors were there. I didn't know that was on the slide. So I can see you on the call, so I think you can briefly respond on behalf of the other recipient, Engineer Adeleye. I think you're on mute. We can't.
We cannot hear you.
Yes, we can't hear you.
Yes.
Yes, we can now. We can.
Okay.
Please proceed.
Sorry. Once again, I want to say thank you, a very big thank you to our branch chairman and to all the members of our branch for all of our cooperative efforts working together. And we, on behalf of other recipients, I want to say a very big thank you once again. We appreciate our working together, and we believe that just like we have been saying, that together we can achieve great things together. And so thank you once again. We'll continue to give our best to the branch and also to NSE at large. And we wish the branch more greater years ahead for everyone. Thank you and have a wonderful evening.
Yeah, thank you so much for that, Engineer Adeyemi Adeleye. And also congratulations on the success of the summer event, which you and the team in Germany organized. We saw the pictures of those on the platform, and it was really exciting to know that our engineers based in Germany could also come together the way we did in Manchester to make sure that they get. Thank you so much for that. Keep up the great job. And we also ask all our other executives and volunteers and members, if there's something you want to do for the branch, you don't have to be an executive. Please get in touch with us. Let's work together to make Manchester branch and NSE great. And I think just to end in the words of our in the slogan of our branch, together we can achieve greatness. So I'll call on Dr. Ataria, our vice chairman, to give vote of thanks on behalf of the branch, and then we can call it a day for this weekend. Thank you. Dr. Ataria, over to you.
Good evening. Sorry, I'm actually on my screen.
I think your volume is quite low.
Is it okay now?
It's very faint.
Wow.
I'm not sure. Is it just me or is it?
Yeah, it's like that over here also.
It's very clear over here.
Oh, okay. Okay. Let me just. I just want to thank everyone for putting out time. Yeah.
I think we can't hear him anymore.
Yeah.
I think we've lost him.
Okay, in that case, we lost you for a moment. Okay, go on quickly while we can still hear you.
Okay, sorry, I was in the car. So I just thank say a big thank you to our speaker who have actually educated us quite a lot in this area of construction industry. Also thanking all the attendees, everyone who have put in our time to come and join us for this great event. It's been impactful, and I'll say a big thank you to everyone, especially our speaker who has impacted quite a lot to every one of us. Thank you once more again. Thank you.
Yeah, thank you so much for that, Dr. Ataria. And I think just one final thing for me to say is, Dr. Aaron, you'll be receiving a certificate from the branch through Dr. Kevin Ano, just to show our appreciation for delivering this guest lecture this evening. Thank you so much, sir.
Thank you. Thank you for having me.
Yes, sir.
It's been such an interesting seeing all the names and some of the faces. Hey, greater things to come, especially the ladies as well. So I hope you guys still hang around for engineers and what engineers can do.
All right. Thank you very much, sir.
Yeah,
Thank
cheers.
you, sir. Do we have anybody who wants to make maybe one or two remarks just before we close for the evening? I'm conscious we have about 12 more minutes. So if we have anyone who wants to make a remarks or make any comment, feel free to raise up your hand, and then would permit you to say something. So we'll just hold on for about a minute. Okay, Engineer Adeleye, go ahead, please.
Yeah, I just want to tell our members that a new batch for the corporate membership application at the NSE HQ in Nigeria has started. So for our members who are interested in becoming a corporate member of the Nigerian Society of Engineers, please get in touch with us at the membership secretariat so that you could be added to our WhatsApp group where we only deal with application matters, and so that you could be part of this last batch of this year. And then because after this October batch, then it's going to be February 2024. That will be the next batch. Thank you. And for current applicants also, please don't hesitate to reach out to us as well, so that we can give you all of the necessary assistances and support needed for you to complete your application. Thank you, and a wonderful evening to everyone.
All right. Thank you so much for that, Engineer Adeleye. Okay, all right. So on behalf of on behalf of Manchester branch, we want to say thank you to everyone for joining. Have a great weekend, and God bless you all.
Thank you, sir.
Thank
All
you.
right, okay,
Yeah.
bye,
Thank
sir.
you. Good evening, everybody.
Thank you.
Yes, thank you.
Thank you.
Yagaban.